problem for the optional exam is to find the center of mass of the semicircle whose center is origin and the radius is r and p equals 2. So the first step would be to sketch it out so we can further visualize what we would want to do. So I'm going to make a graph. And we were told that the center is the origin of the semicircle, and a semicircle is just half of a circle. It's not a good shape. So it's just like this would be a semicircle, and keep in mind that it would make a full circle. And then to start, we think about it conceptually, where the equation of a circle is x squared plus y squared is equal to r squared. And now we can manipulate this equation algebraically to isolate y and make it a regular equation that we could plug in to find the center of mass. So y, we're going to move the x squared over, and we're going to square root this because it's y squared and we only want y, would equal r squared, the square root of r squared minus x squared. And that's our equation. And we know that the center of mass is just like this. It will be in the center of the object. And since we're only looking at the semicircle, it should be around here because it said the center is the origin, which means that we do not have to look for x bar because it will be 0 on the y-axis. To find the y-coordinate, however, we need to use the formula that the center of mass coordinate y will equal 1 over the area times the integral from b to a of 1 over 2 f of x squared. Dx. Now looking closely at this graph, they said that the radius is r, and this would be our radius. So this will be r, and this will be negative r. So this will be our bounds for the integral. And to find the area, we know that an area of a circle is pi r squared. And since it's a semicircle, which is just half a circle, the area will just equal pi r squared over 2. So, I'm just going to simplify before putting it, plugging everything into the equation. We're going to take the 1/2 out because it's a constant. And since it's 1 over a, we're going to flip this around because it would technically be 1 over pi r squared over 2. So the 2 would be multiplied at the top, which would be 2 over pi r squared. And since we're taking the 1/2 because it's a constant, the 2's will cancel out. So what we're going to be putting here is just 1 over pi r squared. And another thing we need to keep in mind is that this function is even because the area that's on this side of the equation will equal what's on this side of the equation. So we can just take it from radius r to 0 instead of radius r to negative radius r and multiply the integral by 2. So what's going to be on the outside as a constant it is going to be 2 pi r squared. But now you can see how I got there. So y will equal 2 over pi r squared from r to 0, and then it's going to be f of x squared, so it's going to be r squared minus x squared, as we've solved right here, squared dx. So luckily, since it's a square root, the square root squared is just going to be the what's inside the square root. So it would we're just integrating r squared minus x squared dx. Now keep in mind, r is a constant. It's a variable, yes, but it's representing a regular number. So it's going to be the same as if we had the number 10 there. It would be, when we integrate, I'm just going to write the constant so we do not forget about it. When we integrate, it's just going to be r squared x, the same way as if a number. We treat it like a number to put another x in. Minus the integration of x squared is x cubed over 3. And the bounds we're using is r and 0. So we are almost done. It will be r squared. We're going to plug everything in. R squared times r is going to be r cubed minus r cubed over 3. And if we put the zeros into this equation, it's just going to be 0. So it's going to be 2 pi r squared times r cubed minus r cubed over 3. And that's just going to be 2 pi r over pi r squared times 2r cubed over 3, which equals 4r over 3 pi. And this is going to be our y value. And keep in mind that it's 0 because the center is at the origin, which means the center of mass is going to stay on the y-axis, as we visually drew it here. So the center of mass is going to have the coordinates 0 and 4r over 3 pi. And this is the center of mass and our answer.